Today, let us look at graphs of a linear equation in two variables. Let us take a point on the xy or Cartesian plane. Now, how many lines could we draw from this point? Maybe 4? Actually, no. We could draw innumerable lines from this point. Now, say we had 2 points on this Cartesian plane. How many lines can be drawn joining these 2 points? Just one. So if we have to draw a line, we need at least 2 points. Let us look at the example we saw in the last lesson. We tried to draw 2x plus y plus 6 equals 0 on the xy plane. We substituted different values for x and found corresponding values for y. And we plotted these points one by one. So we took x equals 0, x equals 1, x equals minus 1, and x equals minus 2. What do you think will happen if we join these 4 points? We would get a straight line. Isn't that interesting? A linear equation in two variables gives us a straight line on the xy plane. Now this looks very cluttered. Let us draw a table where we write the x coordinates in one row and the corresponding y coordinates in the other row. So let us look at the first value. When we put x equals 0, we found that y equals minus 6. For x equals 1, we found that y equals minus 8. When x equals minus 1, y equals minus 4. And for x equals minus 2, we got y equals minus 2. Now this is much neater to look at. We could have chosen any 2 points out of these 4 to draw this given line. It is interesting to note that all points on this line satisfy this equation. Can you imagine the number of solutions this equation has? Yes, infinite. Because a line never ends. So we can plot as many points as we want on this line, and all those points would satisfy this equation. Also, all the points that do not lie on this line, they do not satisfy this equation. In other words, they are not the solutions to this equation, whereas the points lying on this line are all solutions of this equation. Let us look at a few problems. Draw the graph for x minus y equals 2. Now this looks fairly straightforward. Let us draw a neat table representing our x and y values. Now recall that we need only 2 points to draw this line. Why are we sure that it is a line? Because a linear equation in two variables graphically represents a line, as we saw in the last lesson. Alright, let us put x equals 0. Substituting this value in the equation, we get y equals minus 2. Let us fill this value in the table. Next, let us take another value for x. Let us take x equals 1. We get y equals minus 1. Now let us try to draw these 2 points on the xy plane. We get 0, minus 2 somewhere on the y-axis. And we get 1, minus 1. Let us draw this line and label it as x minus y equals 2. Don't forget to put the 2 arrows on either end of your line. Let us look at another problem. Write down the equation in two variables represented in the given graph. Find an equation for another line passing through minus 1, 3. Alright, so we are given an equation in the xy plane. How do we go about finding this equation? Okay, now we can see 3 points on this line. Let us take the trial and error method. Let us randomly write x plus y and substitute values from one of these points. So let us take point A, which is 0, 2. And let us put the values for x and y. So we get 0 plus 2 or 2. Now this gives me x plus y equals 2. Let us see if this equation satisfies the other points. Let us check this with point C, which is minus 1, 3. So if we put these values for x and y, we still get the number 2 on the right hand side. So x plus y equals 2 represents the line shown in this graph. You could check it with point B as well. You would still get a 2. Now we have to find another equation passing through minus 1, 3. Alright, we have already tried x plus y. Now we need another equation. So let us try x minus y. Now let us put the values for x and y. So x is minus 1 and y is 3. We get x minus y equals minus 4. So x minus y equals minus 4 is another line passing through the point C. Instead of x minus y, you could also try minus x plus y or minus x minus y or some other value, say 2x plus y, and just put the values of the coordinate C to get your constant on the right hand side. Let us look at another problem. If the work done by a body on application of a constant force is directly proportional to the distance travelled by the body, express this in the form of an equation in two variables and draw the graph of the same by taking the constant force as 5 units. That's a lot of English. Alright, let us break it into pieces. So work done by a body. So we are dealing with the word work on application of a constant force. So another term is constant force. Now this is directly proportional to the distance travelled. My third term that we're looking at is distance travelled. And if you follow the statement, then we are talking about work done by a body which depends on this constant force and distance travelled. And it is proportional to these. So we can write work equals constant force times distance travelled. Now we have to write this as an equation in two variables. Exactly which two of these are variables? What do you think? Well, the force is given as a constant, so the only two items remaining are work and distance travelled, which have to be our variables. So let us write work as variable y and distance travelled as x. We are also given that the constant force is 5 units. So we get the equation as y equals 5x. Now we have to draw a graph. So let us get a table for x and y and try a few values of x. Let us start with x equals 0. Substituting this value in y equals 5x, we get y equals 0. Let us take another value. Let us take x equals 1. So we get y equals 5 times 1 or 5. Now let us plot these 2 points 0, 0 and 1, 5 on the xy plane. So 0, 0 is the origin itself and 1, 5 lies somewhere in the first quadrant. Let us join these 2 points and label the line as y equals 5x.